Hello, today we're going to be looking at Kirchhoff's current law. This was first described by Gustav Robert Kirchhoff, a 19th century German physicist. Kirchhoff found that the current flowing into a junction or node in a circuit is equal to the current flowing out of that junction. This can also be thought of as the sum of currents in a node equal to zero. Firstly, we're going to explain current. Current is the movement of charge over time. The unit of measurement for current is the amp. Here we see a junction in a circuit with no current flow. Now if we add a current, we can see the arrows show the flow of charge through the junction, with current IS showing the source current or the current flowing into the junction, and I1 and I2 showing the current flowing out of the junction. So KCL shows us that the current flowing into this junction, or RS, is equal to the current flowing out of this junction through both branches on the right. You can think of this like a river, where the water flowing into the river will always be equal to the water flowing out. If the river divides into multiple branches, the new branches of the river will only contain as much water as the parent river. Let's look at an example problem. We're shown a diagram of a node where three branches of a circuit join and asked to find the current leaving the node. At this junction, currents I1 and I2 are shown to be flowing from left to right. We're also told that I1 is equal to 20 milliamps and I2 is equal to 50 milliamps. So how do we solve this? We know from KCL that the current flowing into the node is equal to the current flowing out. So we can say that as I1 and I2 are flowing into this node, the current through the third branch must be flowing out. We can then call this I3. From KCL, we know that I1 plus I2 equals I3. Using this equation and the known values for I1 and I2, we can say I3 is equal to 20 milliamps plus 50 milliamps. This means I3 is equal to 70 milliamps, and we have our solution. Now on to the next sample question. In this example question, we're given a diagram of a node, along with three currents, I1, I2, and I4. I1 is shown to be equal to 40 milliamps, I2 is 30 milliamps, and I4 is 50 milliamps. We're asked to find current I3. We know using KCL that the current flowing into the node must be equal to the current flowing out. So, using the diagram, we can say I1 plus I2 plus I3 is equal to I4. Substituting in these values and rearranging the equation, we can see that I3 is equal to 50 minus 70 milliamps. This means I3 is equal to negative 20 milliamps. From this negative magnitude, we know that I3 flows in the opposite direction to what was originally assumed, meaning I3 flows out of the node at a magnitude of 20 milliamps. Thank you very much for watching, and I hope you enjoyed the video.